All right, number 54 has been giving people a lot of problems, mainly because it's on the extreme math end of things. Okay, a train car going at this many miles an hour and accelerating at this rate leaves Boston at 10:52 p.m. kind of a problem. Okay, all right. Two cars drive on a straight highway at time t equals 0. Car 1 passes mile marker 0, traveling due east with a speed of 20.0 meters per second. At the same time, car 2 is 1.0 kilometers east of mile marker 0, traveling at 30.0 meters per second due west. Car 1 is speeding up with an acceleration of magnitude 2.5 meters per second squared, and car 2 is slowing down with an acceleration of magnitude 3.2 meters per second squared. Part A, write x versus t equations of motion for both cars. So x as a function of t. Taking east as the positive direction. Part B, at what time do the cars pass next to one another? Okay, here's what we're going to do. We're going to read through the problem, and we're going to stop every sentence or half sentence or so when they give us information. Now, the equation up here that has x as a function of t is, with acceleration in it, is this second one here. All right, so we're going to make everything fit into this one, although I will say x initial and x final instead of that. Okay, so first we're going to go back through the problem and pick out our variables. Two cars drive on a straight highway at time t equals 0. Car 1 passes mile marker 0, traveling due east with a speed of 20.0 meters per second. Name a variable they just gave me. Okay, fine. They said time initial equals 0. Position. Okay, position of which car? Car 1 when? At time 0. So V1 initial is equal to 0. Okay, they also in that sentence gave us what? Yeah, they gave us a velocity. And they're only talking about car 1, and that was its initial velocity. So V1 initial was equal to 20.0 meters per second on this one. Now, they said traveling east, and at the end of the problem that I read through in part A, they said taking east as the positive direction. Now, since east goes to the right, we have a tendency to make it positive anyway. All right, just because it lines up with an x-axis if you're glancing at a map. Right? So I am going to emphasize that this is in the positive direction with a plus. Second sentence. At the same time, car 2 is 1.0 kilometers east of mile marker 0, traveling at 30.0 meters per second due west. All right, so it's the same time. I'm not going to write that down twice. But x2 initial is equal to 1.0 kilometers, or 1.0 times 10 to the third meters. And they said east of mile marker 0. So is that positive or negative? They said east, so it's positive. Okay, mile marker 0 is where we started where car 1 started at. Okay, then they gave us the velocity of car 2, what it started off at initially. It said it was going 30.0 meters per second west. West is what? Negative. So we put a big negative there. All right. Third sentence tells us the acceleration. Car 1 is speeding up with an acceleration of magnitude 2.5. So acceleration 1 has a magnitude of 2.5 meters per second squared. Okay, car 1 is speeding up. So does the acceleration go in the same direction as the velocity? Yes. So it is positive. And then it says that car 2 is slowing down with an acceleration of magnitude 3.2. So that means that acceleration 2 is negative 3.2 meters per second squared. Hold on a second. V2 initial. Second due west. Oh, wow. Huh. I think we wrote it down wrong last period. Oopsie, I'm going to have to tell period 5? Yeah, to check the video that I post. Okay. All right, now we're going to go with that equation up there. So x, and I'm going to say final, is equal to, and I'm going to just say, I'm talking about my first car, x1 final is equal to x1 initial, which we all know that part's 0, plus v initial, that's v1 initial, multiplied by time, and I'm just going to go with t since we did start at 0, plus 1/2 the acceleration of car 1 multiplied by the time squared. Then we have for velocity for the second car, x2 final is equal to x2 initial, which was not 0, so we don't cross it off, plus v2 initial, which was negative, multiplied by time, plus 1/2 its acceleration times the time squared. When you put numbers on these, you will get your answers for part A. Okay? Part A had numbers to it, and if we were summarizing our problem, A, we would say x as a function of t equals what? All right? So we want x1 final equals a number times t, a measurement times t, I should say, plus 1/2 another measurement times t squared, and the same deal for here. Now, for part B, we want to know t equals what when they pass each other. When they pass each other, x1 final is equal to x2 final. They are both at the same point at the same time. Okay? Now, in order to do that, we are going to set this guy equal to this guy, solve it for t. Now, you should see, approaching in the near future, a quadratic equation galloping at us. The quadratic equation, t, because we're not solving for x, we're solving for t, is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, now for the fun part of figuring out what a, b, and c is. We're going to set this one equal to this one. And then we're going to bring these guys over to the other side so we have it equal to 0. Right? I'm going to skip a couple of steps here and jump to the fact that we've got 0 is equal to 1/2 times a squared minus, I'm sorry, not a squared, a2 minus a1 times t squared plus v2 initial minus v1 initial multiplied by t plus x2 initial. Okay, you can figure out getting your math to that stage. That means that this guy here is equal to a, as far as the quadratic equation goes. This guy here is equal to b, and this little guy here is equal to c. Make sure that he is 1,000 meters and not 1 kilometer. Yes? Okay. What I did is I set this equal to this. So I've got this term plus this term plus this term equals this term plus this term. Right? Then I wanted to get them all on one side, so I subtracted this one and this one over to the other side. So I ended up with v2 initial minus v1 initial multiplied by t. And I had 1/2 in both of these terms times a2 minus a1 multiplied by t squared. All those things were equal to 0. In order to set it to the quadratic equation format, you need the squared variable terms first, then the singular variable terms, and then the constant at the end. Okay. Another way of looking at this is that I combined this equation with this equation by making this top equation negative and adding the two together. Because then I had this minus that, and they were the same thing. I had this minus this, and which that guy was 0, so we're left with this guy. This one minus this one, that's what I got here. This one minus this one, that's what I've got here. Okay, so a couple of different ways of looking at combining your two equations to combine your two equations to solve for your one unknown, which in this case is t. All right. From that point forward, it's a lovely adventure in mathematics. Good luck.